Hi. Now in this tutorial what I want to do is show you through an example how we calculate an area trapped between two graphs. And the example I've picked here is the area trapped between y equals x, that's this blue line here, and the curve y equals x squared, the red graph here. That area is shaded green. Now to do questions like this we need to first of all find out where the graphs intersect. Well, we'll do that in a moment. But let's just imagine we know where the graphs intersect, here and here. What I'm going to do is essentially say that this is equal to, this green area that is equal to the area below the graph of y equals x between those points of intersection. You'll see we get this kind of triangle, okay, that I've shaded in blue. And what I'm going to do after that is to subtract the area below the graph of y equals x squared, the area I've shaded here in red. So if I remove this red area from the blue area, I'm going to get the green area. Now to do this, I do need this point of intersection here. It looks like they intersect at the origin, but in order to be sure, what we've got to do to find these points of intersection is solve the two equations simultaneously. So if we were just to say for the points of intersection, I'll just say for points, okay, abbreviate that, of intersection, what we need to do is find out where x squared equals x. So we would have therefore x squared equals x. I would subtract x from both sides and get x squared minus x equals 0. Pull out a common factor of x and we'd have x times x minus 1 equals 0. And so therefore either of these factors would equal 0. So this factor x would equal 0 or x minus 1 would equal 0, leading to x equals 1. It's worthwhile finding out what the corresponding y coordinates are. We can just simply substitute when x is 0, say, into here, y equals x, and we can see that when x is 0, y is also 0, and similarly when x is 1, y will be equal to 1 because it equals x. Alright? So we've got our points of intersection. Let's just put them on the graph. We've got when x is 0, y is 0, so it goes through the origin. And we know that this point of intersection here has coordinates 1, 1. So this point below here is 1. We can update this diagram. That's the origin, that's 1, okay, and this point here is 1, 1. And the same applies to this diagram over here. Okay, so I've updated the diagrams. So how do we go about finding these areas? Well, there's several ways that we could go about finding this area here. Let's just say we call it A. The standard way is to use integration, to integrate your equation of your curve with respect to x between the limits, in this case 0 to 1. We could do that. Let's just show you. Area of A equals the integral from 0 to 1 of our equation. In this case it's going to be x with respect to x. And if we do that, we integrate that, we're going to get x squared over 2. Put that between the limits of 0 and 1. And we've got to put the 1 through first of all, so we've got 1 squared over 2, that's going to be a half. And then we would subtract what we get when we put 0 through, which is 0, so that's going to give us a half. So the area of A is going to be half a square unit. The thing is though, quite often in questions like this you end up with a geometrical shape. In this case we've got a triangle, and so therefore instead of using integration I could have used just the basic formula for the area of a triangle. So I could have said, or the area of A, knowing that the area of a triangle is half the base times the height, The base here is 1 unit, so I could say times 1. And because we worked out the corresponding y value, which turned out to be 1 when x was 1, we've got the height here as 1 unit. So half of 1 times 1 is just going to be half. So we can see that the area of A is going to be half a square unit, whether it be through integration or using the area of a triangle in this case. Okay, well that's the area of A. We can work out this red area here, which I'll call B. Being a curve, it's not a geometrical shape, so we've got to use integration here. So we could say area of B equals, we'd integrate the equation of the curve, in this case x squared, with respect to x, and our limits go from x is 0 to 1. So we'll put x going from 0 to 1. If we work this out, integrate x squared, we're going to have x cubed over 3. Put in our square brackets with the limits at the end going from 0 to 1. Make our substitution for x being 1, and we've got 1 cubed over 3, which is the third, and then we would subtract 0. When we put 0 through, we've got 0 cubed over 3, that's 0. Third take away 0, that's going to be a third. So we now find that we can work out the area that we require, the green shaded area here, because it's just going to be the area of A minus the area of B. So we can say that the shaded area is going to equal the area of A, which is a half then, take away the area of B, which is a third, take those away from one another, and what you end up with is equal to 1/6. And because we're working out an area, it's a good idea just to put square units, I feel, on the end there. Now, there is this way that you can do this. Some people might prefer to do it like this. Let's just border this off. I haven't got much room here, but we should be able to just squeeze it in. Okay? Some people might just go for the area straight away as being the integral from 0 to 1 of, now we see this situation and we see that what we could do is just work out the area underneath the graph of x, take away the area underneath the graph of x squared. So we could say integrate x minus x squared with respect to x. You've got to be very careful though in situations like this when you've got areas that are underneath the x-axis though. So personally I don't often use this technique, but it will work in this situation anyway. If we work this out, integrate x, we're going to have x squared over 2. Integrate x squared, we've got x cubed over 3. And this will be between the limits then of 0 to 1. Substitute our 1 through, first of all, then we're going to have a half, and then minus a third here. Take away what we get when we substitute the 0 through, which is going to be 0, take away 0, basically 0. So we end up with half take away a third again, what we had over here. And that's going to be then 1/6 square units. Alright, so we've got this way as well that we could apply to this question. Personally though, as I say, I generally prefer working it out in stages though, something like this, especially if a problem becomes more complex. Anyway, I hope that's given you an idea, and that brings us now to the end of this tutorial.